find the distance between 2 points. So the points are x1, y1, and x2, y2. Those are given to us in the problem. And don't be bothered by these subscripts. They just mean this is the x-coordinate for the first point and the y-coordinate for the first point. And then this is the x-coordinate of the second point and the y-coordinate of the second point. So those 1 and 2s are just labeling which point you're talking about. So we'll just label this point 1, and we'll label this one point 2. So the points that were given in this example are 2, 5, and 4, 1. And I want to go through this problem to finding the distance between the 2 points without using the formula, because I kind of want to give you an idea of where it came from, where the formula comes from. And you can choose how you want to find the distance between 2 points. So we're in the rectangular coordinate system. So it's helpful for me to recognize that I have a rectangle here. Whenever you have 2 points like this, you can draw a rectangle. Really, I'm just drawing half of a rectangle, which is a triangle. And the reason why I want to do that is because I want to use the Pythagorean theorem. And the Pythagorean theorem, if you recall, says that if we label this triangle A, B, C, or the sides of the triangle A, B, and C, then really what I'm doing to find the distance between these 2 points, I want to find what C is. That's the length of this line segment. And so the relationship between A, B, and C by the Pythagorean theorem, and you should have seen this before. So this is a review. The Pythagorean theorem simply says that A squared plus B squared equals C squared. Okay, and I'm looking for C. So in order to find C, I just simply need to take the square root of both sides, and so that gives me that C is the square root of A squared plus B squared. And you can kind of see where this is going, because D has the sum of squares in here as well, and you're taking the square root. So it turns out to find A, I'm really just taking the difference between these 2 points in the x direction. So here x is 4, here x is 2, so to go from 2 to 4, that's 2 units. And that's found just by subtracting the x values. So 0.2, 4 minus 2 gives me 2. So A is just 2. So I'm going to have 2 squared under the radical there. And then I do the same thing for B. Now we're looking vertically. We're moving from a height of 1 up to a height of 5. So we're just taking the difference, 5 minus 1, to get 4 units. And you can see that this length is 1, 2, 3, 4 units. You're just taking the difference between the y's. So 5 minus 1 is 4. And so in the formula, that becomes 4 squared under the radical. So now, using the Pythagorean theorem, we have the square root of 4 plus 16, and that is simply the square root of 20, which I'll show you how to do this in another video, is 2 square root of 5, and if you use your calculator, it's approximately equal to 4.5. So C is about 4.5 when we round to the nearest 10th place. And I found the distance between those 2 points. Had I used the formula, I would have just plugged in x2, x1, y2, y1, and I would have gotten D equals the square root. So here's my second point. X2 is 4, x1 is 2, so I have 4 minus 2, and I'm going to square that, plus y2 is 1, and y1 is 5, so I'm going to take 1 minus 5, and it doesn't matter that I get negative 4 there because I'm going to square it, and that still gives me 16. So now the distance becomes the square root. This 4 minus 2 is 2 squared plus 1 minus 4 is negative 4 squared, and that becomes the square root of 4 plus 16, and this seems familiar here, square root of 20, which is approximately equal to 4.5. So the formula gets me obviously the same result, but I wanted to show you, where does this formula come from? It comes from the Pythagorean theorem. So if you forget the distance formula and you remember the Pythagorean theorem, you can still find the distance.